I need to remind you that we will have a giveaway organized by the BGK, Bank Gospodarstwa Krajowego. You need to fill out a form and you can win a voucher Sodexo 100 zł. So if you still haven't done that, you might just do as well. The raffle will begin after this presentation. And right now we have Roberto Cortez from Red Hat.
Hi everyone, thank you so much for joining my session. I know that usually the lunchtime, or actually the session after lunchtime is really problematic because people are just like a little bit tired with all the food, so I hope they're not going to be too much boring. I have to say it's really great to be back in Krakow. I mean, I am not in this conference. I have some fond memories because that's actually when I started my international speaking career, was here in Krakow in another conference, so it's really great to be back. And especially it's really great to be back also in live events, not only events from our living room, right? Anyway, so this session for today is going to be developer joys with Quarkus. Let me ask you a really quick raise of hands. Has anyone here heard about Quarkus before? Well, a lot of you in the room. Are you using Quarkus actually? Well, come on, that's fine. So. That's great because that tells me that, well, you heard about Quarkus, so maybe you don't know what we do in Quarkus, except for people that use it. So I hope that I'm going to show you some things in Quarkus that you're going to enjoy, and maybe when you get home or when you get to your work, you might be able to start using it, right? So the idea is that you'll be able to find ways that you'll be happy to develop with Quarkus. But before that, I have a bunch of demos for you to show. I hope all of them will go okay. I usually have to sacrifice like a piece of hardware for the demo gods, so I hope that that goes okay. Now, I want to just give you like a brief introduction and tell you what Quarkus is and the internals for you to at least understand what everything that I'm going to tell you hopefully will be true, right? Now, Quarkus itself is an open source stack. It's tailored to write Java applications. We like to call it, well, it's cloud native. I mean, all all these nice words that you hear these days for microservice, for serverless, but it's way, way more than that. So if you want to build monoliths, if you want to build command line applications, you're also able to do that with Quarkus. So you can pretty much build everything that you want in Quarkus, but the main idea when we started Quarkus was to build these kind of architectures. Okay, now the next question you're probably figuring out is, okay, why another framework? Why another runtime? Why do we care about this? Why Quarkus? And we have to take a step back to answer that question. We like to call this the hidden truths about Java and containers. So I'm not going to go into too much details about the Java memory model. I think there was a couple of sessions about that. But I think all of you, at least hopefully all of you already have a good idea that, for instance, one of the things that Java when the JVM is starting up, right, has to load classes on memory. And every time that the JVM loads classes in memory, they never go away. So they'll stay there forever until you shut down the JVM. Of course, it's going to occupy memory, right, and it's going to occupy resources. And remember that sometimes this happens when the JVM is only loading a few classes to do like a single execution about them, and then it's done, right? They're not going to execute that when you're running the application. It's only maybe to do some bootstrap, to, I don't know, read an XML file, and then you don't need to read it anymore. But those classes still stay there, right? And they're going to occupy that memory. Now, you probably also heard that other technologies are like less heavyweight than Java, right? And unfortunately, maybe that's true. I don't want to start like a debate here between all of these technologies, but in fact, there are reasons for this, right? And Java also has other advantages than these technologies, but in the end, a lot of people will only look into some of these numbers and say, oh, that technology uses less memory, so it's better, I want to use that. So we want to be competitive with other technologies, still offer the same amount of things that you find in the Java community, you find in all the Java ecosystem, but also be competitive memory-wise and CPU-wise against other technologies. Now, why is this relevant? So let's take another step back, maybe like 20 years ago. Have you ever had to go by a process of like acquiring hardware to run your software? acquiring hardware, so buying like a server, buying a rack, right? A few of them. You know that that costs a lot, right? You have to make like an upfront cost. That's, I mean, buying a hardware machine is really expensive, right? And usually because you're required to ask for budget approval, you always ask it way more than you needed, and you buy like a bigger machine just to make sure that you're able to going to scale your application because you didn't know about it. So this actually is not problematic in sense, but if you look on how things are being deployed these days on the cloud, you actually pay for what you actually use, right? So if you compare with both approaches, you didn't care, I mean, you will care by the memory that your application will use, but you didn't care that much because the upfront cost was already there on your server, right? You already pay for that. So if you were using it or not, it was your issue or it was your problem, but you didn't care. You were just, okay, it doesn't matter if the app was using like a gig of memory. We have like 4 or 5, let's just put it over there. But when you're running things on the cloud, things become way different, right? Because you're going to have to pay exactly for what you use, right? So it's going to increase your cloud costs. And then when you're starting to see all of these bills coming up every month, then people are going to start asking about it. So this is why we started to look into things in a different way, right? We started to look into things on how we can save memory, how we can save CPU, and also be competitive with the other technologies. Now, of course, all of these graphs are not to scale, but the experience that we're having, for instance, with the Quarkus deployment, that we're able to fit way more runtimes that are using Quarkus compared to the same amount of resources that you will use to deploy a traditional Java application. I'm going to tell you how we do that, but we know that this is a hard sell, right? So just selling performance, just selling memory costs, just selling CPU costs is not, I mean, it is an important thing, but we also like to give you an environment that you're comfortable to develop with. So we came up with a few things that we expect that's going to be helpful for you to develop these kind of applications. So one of the things is we try to streamline as much as possible how you'll develop a Quarkus application. So one of the things that we're most proud of is our live reloading feature. The live reloading feature is something that you start Quarkus as a development mode, you write your code, you don't have to start and start the server, you just hit refresh, and we just reload all the code for you. It actually works. It works with everything. And if it doesn't work, please report me the issue because that's a bug. So everything that you write is auto-reloadable by Quarkus, and you don't have to do anything more than that. So it's really great because it doesn't interrupt your flow. I'm going to show you a couple of demos of how that works. Going back to, for you to have like a comparison on memory sizes, so a traditional, and this was just taken like maybe like a few months ago, but a traditional native stack, maybe like we're talking like 130 meg, more or less. What we're seeing is that Quarkus takes like half of that size. And if you're building Quarkus in native, and I'm going to talk about Quarkus native in further into the presentation, we're seeing like a tenth of that size, so around 10 meg, which is pretty impressive without any loss of functionality. And these other examples just a REST plus the CRUD, so REST endpoint and database. So we still see like an increase on memory. But again, if you compare it with the traditional cloud stack of Java, we're going to see less memory usage. And now it's 200 versus 145. And again, on the native mode, you'll see like a tenth of the size, so 28 meg. Now, this is relevant, again, when we pick up the cloud example, right? So right now, people are deploying applications in 100 nodes, right? So if you multiply 50 meg by 100 nodes, well, that's a lot of memory, and that's a lot of cloud cost. So if you're able to save a few bytes here and there, well, all of that is going to add up, right? The same thing is for startup time. So who has an application, is working in a Java application that starts in more than 10 seconds? Most of the room. OK, so we are able to start Quarkus in only a couple of seconds. Compared to, so usually an application that starts in 10 seconds, usually in Quarkus will take like 2 or 3, or even less. If you're starting about Quarkus native, you're talking about sub-millisecond startup time. So we're starting like Quarkus in around like 15 milliseconds, 20 milliseconds. It really, well, it's also going to depend on the load of your machine, but you get the numbers ideas. Another thing that we tried to come up, especially because there is this trend about people writing reactive applications, we wanted, and you know that this writing reactive code is really, really hard. So we're trying to unify the imperative style and the reactive style. So the Quarkus APIs to write reactive code are pretty much the same as you will write any REST endpoint. You just change a couple of annotations, and then you get the reactive REST endpoint out of the box. So here's a very simple example. So it's just exactly the same. You just, of course, change. You cannot just use a service directly because you have like a different model, but it's very similar, right? So you don't have to learn a completely new API just to do that. And finally, we like to joke about something. So Quarkus is only right now 3 years old, but we like to joke that probably you already have experience building Quarkus applications, and you have probably 10 or even more years of experience if you're going to write a Quarkus application right now. And the reason for this is because while we do add a few Quarkus APIs here and there, most of the APIs that Quarkus uses are already APIs that exist out there, right? So you can use Jakarta APIs, you can use microprofile APIs, you can use Kafka APIs, you can use everything that's available on the ecosystem. So really, a really interesting question now. Who's here a Spring user or a Spring developer? OK, most of the room. Do you know that you're able to use Spring APIs to run Quarkus applications? Yes, so you're going to be able to. You don't have to leave. We don't support all the Spring APIs, all the most popular ones. So if you want us to support more, you just can tell us, we can add them more. But the interesting thing is, even if you don't know any of these APIs, but you know Spring, you can come to Quarkus and you have all the benefits, and you'll still be able to write using Spring APIs. OK, all of this looks good, right? So let me try to tell you how we do this for you to be able to convince that what I'm saying actually is true, right? So traditionally, that's how traditional frameworks start and run, right? So you have your application, you build it with a build tool like Maven or Gradle, and you're done. You have like a jar file, you have a war file, right? And then you run that jar file or war file either on a Tomcat server or it's just an executable jar. But when you run it, that's actually when a lot of the work's going to be done, right? That's when it's going to be things like class path scanning happening to find out your annotations, to create proxies, to create a bunch of things, right? Create thread pools. So all of these, we can say that's initialization code or initialization or bootstrap code that's been happening basically to be able to start up your application and run it, right? So what we did with Quarkus is we shifted things around, and we are pushing everything that we can for build time. So the idea here is when we're building Quarkus, we look into the entire application, and we do a lot of, well, I'll say crazy things, but we look into the application and try to bootstrap as much as possible so we save time during runtime. So a very simple example. If you have to load an XML file, and we see that you're loading that XML file, but that XML file is already on your application, we can just load it and serialize the data into Quarkus memory. And what we do then is we just drop the XML file, we drop all the dependencies, we drop all the code of the XML file, and you're done. So we do that automatically. But the idea with this is we're saving time by reading that file beforehand during build time. We're saving memory by dropping all the classes that are required to read XML because we don't need it anymore. We already read the XML, right? So, and in the end, it's going to have two results also when you run it in runtime, is less classes being loaded, so less memory, right? And less startup time because you already done those operations during build time. And if you think about it, this makes sense, right? Why are you going to execute the exact same steps every time when you're running your application in 100 nodes, right? If you run the same version of your application in 100 nodes or even more, the same steps of bootstrap execution are going to be executed on every single node, which can be done previously. And that's what we do in Quarkus. We try to do as much as possible during build. So when you run your application, then the application is, I will say, more ready to start. And it's going to take less time, it's going to take less memory. So The idea over here, again, is try to move as much as possible from runtime to build time. We minimize the runtime dependency, so the example as XML was 1. But now if you apply these to pretty much everything, right? So the XML example maybe is just like a small gain, but the idea is you keep applying the same pattern, this same behavior to all the application, to the entire framework or the entire runtime. All of these things are going to add up, right? And in the end, you're going to get a more higher, a more major saving cost in both memory and CPU. Now, one of the main motivations for us to start with Quarkus like this was to be able to have these optimizations to run these with native image in GraalVM. Have you heard about GraalVM and native image? Okay, most of you. I'm going to explain that a little bit further. But when you're running an application in native image and in GraalVM, you have certain limitations, and you have to do these kind of operations to be able to run that over there properly. Okay, so to summarize, benefits are we do the work once, not at every start, right? A lot of the classes that are required for Bootstrap, they're no longer needed, so we can drop those away, right? Less time start, less memory. And we also do some other stuff, right? So we try to remove as much as possible reflection and dynamic proxies, because we know those are the things that also take memory, also take execution time. And when we are analyzing the application during build, then we are able to actually figure out where do you need the reflection call, where do you need dynamic classifier. And what we do is we write the bytecode required to replace those calls. And it's just basically a single method call, which is going to be much faster to be executed. Okay, so you may be wondering, well, all that looks great, but how are you able to do that with all the libraries out there? Or do we have to use something specific? So Quarkus itself, you can use any library that exists on the ecosystem right now. The only difference is you require what we call a Quarkus extension to benefit from all this that I mentioned, right? Because like a common library out there doesn't have these mechanism, doesn't know these things about build time, runtime, these optimizations. So what we do is we usually have what we call a Quarkus extension around a certain library, let's just say Hibernate or something like that, and then we provide those optimizations on top of the extension. Then you can just use the extension in Quarkus to be able to get these benefits out of Quarkus. But you can use any library that's on the ecosystem right now. Quarkus is just a simple Java runtime. It will work with Java. It's just if you use that library without the Quarkus extension, then you're not going to have these benefits. But that's fine. Quarkus extensions, we support most of the popular stuff. And if there is no Quarkus extension to do that, well, you can write it one yourself, or you can ask the community to help you or to help write that. And we have a lot of examples of like community contributed extensions to do these kinds of work. So Quarkus is not such like not just a native compiler, not just for Kubernetes. Maybe you heard some of these things in the past. I believe that Quarkus is way, way more than that. Don't think about Quarkus as something that's copying Spring. No, we don't want to copy Spring. We want to do our own thing. It's not only for small applications, not only for microservices. You can build monoliths for that. One of the interesting use cases we've been seeing recently is people running Quarkus in ARMs or in Raspberry Pis, because I mean, since the memory requirements and CPU requirements are so low for Quarkus, they are perfect for these kind of environments. So even people writing them to write command line applications and then building native, then you can just run them on any box, which is really cool. Okay, native image. So for native image, there is a project called GraalVM. It's coming from Oracle Labs. It is a very interesting project. So it runs as a regular VM, but has a couple of differences. But one of the features we're interested in GraalVM is something that's called the native image compilation. So native image compilation, what it does is it actually picks up your application and builds it as a native executable for your system, meaning that when you run it, there is no JVM anymore. There's going to be still a VM involved, in this case called substrat VM, but there's no JVM. Everything is built natively, compiled to your system, and you're done. Now, the issue with this, as you may be wondering, is there are a lot, because you're not running on a JVM anymore, so a lot of the features of the JVM are not going to work, right? So for instance, things like reflection, yes, they do work, but you need to provide a list of things you're going to call by reflection, right? Because you're building the application natively, right? The application is going to include everything that requires to run. So if you don't provide a list of reflection calls that you require, the application doesn't know which reflection calls are going to require, right? So in the end, it could need to include the entire JVM, and that's not the goal, right? The goal is to try to slim down the native image as much as possible, of course, to be more performant and have like a less disk size. And then there are other things that are not complete and that are not supported at all, like dynamic class loading. I mean, we're talking, so a native image is a closed world view of your application, right? So you're not able to load stuff like we do on JVM. So now I think you're starting to link why we start to do all of these optimizations into Quarkus, because the end goal was to be able to actually build the application to native. And for that reason, we had to do a lot of stuff, like removing reflection, trying to remove all the dynamic class loading, remove dynamic proxies, because those things are either not working on native image or do not work very well with the native image. So that's why we do a lot of these, why we do a lot of this into Quarkus. Okay, so hopefully that was not too boring. Let's go to the more interesting part, which is demos. I hope that you have a pretty rough idea on how Quarkus works and what Quarkus is right now. So all the things I'm going to show you are from this link, but I'll show you that in the end as well. And so let's go here to my IDE. Let's put this into presentation mode. Is black OK, or do you want me to change to white? Is black OK? Yeah. Wonderful. So actually, before going there, if you want to start a Quarkus application, one of the things that you can do is you go to this website over here. It's called codequarkus.io. So you just come over here, you'll just say, hey, I want an application of Quarkus. You can just pick, you'll see all the extensions that are already available into Quarkus. So you'll see just like a huge amount of extensions already. You just pick whatever you want. You just download the app, and you have like a bootstrap application that you can start out of the box. I'm not going to do that because that's going to take some time, and the internet is not really reliable. So I'm going to show you here a couple examples that I have. So one of the first things is I have here like a service called Number API, and I have another one called Book API. The idea is that there are like two services. Number API generates an ESBN for the book, so nothing out of the ordinary. So the first thing I'm going to do here is I'm going to go to source. I'm going to say like find files, and I'm going to search for Quarkus. So the only thing that you're seeing, which is Quarkus, is like Quarkus configuration, right? They're like Quarkus packages, but they are not Quarkus APIs. They're actually part of the package name of my project. So there doesn't seem to be any Quarkus APIs over here, right? There's nothing. So if I show you the code, and here is just a resource, right? So do you recognize this code? A few? OK. I know this is not Spring code, but I'll show you the Spring version in a sec. But this is actually using JAX-RS, right? So the now Jakarta, still Javax at this version. This is just like an interface with a REST endpoint and a couple of annotations for OpenAPI. And here is the implementation of the service, nothing out of the ordinary. But you see, you probably already built something similar, and you haven't. There is no Quarkus code here. It's just like simple things. What you're going to find Quarkus stuff is actually on the POM file. So on the POM file now, you're going to see dependencies are actually Quarkus extensions. So to breach where I tell you that yes, you can use whatever library is out there, but if you want to get the benefits, well, you have to use Quarkus Extensions because those are the ones that do the magic. But you also see other dependencies like rest assured, right? These are only for testing. We don't really need to do anything out for that. So what I'm going to do right now is I'm just going to run this in development mode. So this is Quarkus dev. And I should have it starting up right here. So this is book API, these numbers. So let's go over here. Yeah, so yeah, this is just the Quarkus console. It will show you what's happening over there. Give you like a couple of endpoints with like health and metrics, so like nothing out in particularly. You have the dev UI. So dev UI will show you all the extensions that are added by the application from Quarkus, and then all of them will either have like a way to interact with Quarkus. For instance, configuration, you have like a config editor over here, and you can edit the configuration. Or you have just, for instance, here, the direct links to the documentation for this particular extension. So it's pretty useful to navigate and see. But let's show one of the most interesting things, right? So I'm over here. I'm here on my REST endpoint. And, oops, sorry. That's not what I wanted to do. Actually, closes IntelliJ by accident. Doesn't matter. Let's go over here. So I'm going to like invoke that REST endpoint. So it's just generating a couple of random numbers. That's for the SPN of the book. And let's put that on presentation mode again. And I'm just going to remove this, and I'll say hello JDD. And I'm going to call curl again. Oops, what went wrong? Oh, yeah, that's missing. And there you go. Hello, well, it's probably, let me just clear. And you get hello JDD. And you've seen that I haven't really touched the server. I run just Quarkus dev and just let it over there, right? Yeah, but yeah, that's just a very simple use case, right? That's fine. Let's go with a more tricky one. So I'll just create like a new endpoint, and I actually create like an actual hello stuff. So hello, and we don't have to be a response. I can just be like a regular string, and yes, let's say return hello JDD. Actually, like that. We do have to put the method invocation here to put the annotation. So this is going to be a get. And, well, the path, of course, is going to be /hello. I haven't touched the server, right? It's still running over there. It's there, haven't touched that. And, well, now I'm going to just say here and say curl hello. And I get hello JDD. And if I keep just changing this, right, let's put like some extra exclamation points. That was not on the right one, or was it? Let's see. There you go. So as you can see, we're able to just change the code as much as we want, and Quarkus just reload it for us. And you can do things like change attributes on the database, add columns. I mean, if you're doing a Quarkus change, and if it doesn't work, that's a bug, and you should report that. Really, everything should work out of the box with this feature. So this is one of the things that we love the most. Now let me show you something else. So now we're actually going to use like a Quarkus API, well, just an annotation. And I'm going to implement a test. So I'll just call it like number API test. And for this one, yes, we're just going to use, to have a Quarkus test, you have to call this with annotation Quarkus test, because it's going to bootstrap the Quarkus environment for the test using this annotation. And I'm going to put like a test method over here saying, well, hello. Now let's go back into the console. You may be seeing that it's got here in the bottom. I'm not sure if I'm able to push this forward because that's how I can probably push the terminal up. So like this. Okay. And you'll see something like say test pause. What is that? So this is what we call our test continuous testing feature, right? So what I'm going to do is just hit resume, and you'll see there were like 3 tests that were passing, and 0 tests were run in like 13 seconds, and blah blah blah, right? So the idea with this is I'm actually able to write my tests, change them, and then Quarkus is actually smart enough to understand which code did you change and run the test on the fly to figure out if what you wrote actually broke any test. It's not going to run all the tests, just going to run the tests that you require, right? So for instance, those tests that were executed were right here. So let's just say I'm going to put something like this, and I haven't touched the server, right? So it just automatically detected that I changed something, and you'll see that there were a few tests failing, right? And well, if I roll back, then everything is passing again, right? But actually, let me implement the other one that I added over here. So let's just go here. So this is using rest assured. I'm going to call numbers hello. That was the endpoint that we added a while ago. And if you come over here, you'll just see. Now notice that only one test was run. So the only test that was run was the test that was executing the REST endpoint. So Quarkus was able to figure out, OK, this was the code that will change. So I only need to run this test. That's the one that I'm going to execute, right? And well, it's failing because I'm sorting like this. So well, let me just copy this part, and let's save it over here. And now everything is great, right? This is completely optional, right? So I have it disabled. So when you start up with Quarkus Dev, it's disabled by default. You want to enable, but I think it's really useful. Some people like it, some people don't. But again, I think it's really impressive what we're able to do with Quarkus. OK, so this was dev mode. Let me show you how. Let me just roll back all the stuff. So we start from a fresh endpoint, or from a fresh thing. And I'm just, let me just clear that up so you can see the command. So I'm just building the app. I put like a couple of parameters over there. Those are Quarkus parameters, and you see Quarkus container image build and Quarkus Kubernetes deploy. So just by passing these parameters and with the Quarkus extensions that are already existing in the app, so Quarkus is just going to create a Docker image. It's going to deploy that Docker image in a cloud environment. Well, because the internet is reliable, I'm actually deploying in a Minikube environment that I have here running locally. But just with those commands, and actually it failed. Oh, it failed because I changed it. I didn't clean the code because I changed the code over there, and it failed the test. So let me clean that up. The issue over here is because it's missing the class that I added, because I removed that. So it was nothing to do with Quarkus, just Maven stuff. Let's try to build that again. Yeah, but the idea over here is just going to build the Docker image, going to run the test on the Docker image. Right? That's why I run in Verify. And then it's going to deploy that into Minikube. Well, or you can just deploy it on Amazon, wherever. You just pick wherever you want to run that. So here I'm running the integration test. So if you're looking over there, it's just pulling the image that I just created. So it's actually running the test against the Docker image that you just generated by Quarkus. And now that is done, so we can just go and see kubectl get pods. It's not ready yet. So let's go and say logs. So that's over there. That's the same service that I was running before. And well, I can call curl on that, and you get the number, right? So now let me do like something very interesting. So I'm going to do Quarkus remote dev. What do you guys think this is going to do? So this is going to give you the exact same developer experience, but now connected to a Docker container running into a Kubernetes cluster. Well, it's not going to be as fast, right? Because it needs to like create the new jar file and then push it for the wire to the Docker container. But in here, let me just change that again. Hello, JDD. And curl that. And now you get hello, JDD. So now what you're getting is you get hot reloading directly from a Kubernetes cluster from a Docker container with Quarkus. Yeah, you may be asking, well, that's crazy. Why are you going to need something like that? Well, imagine that you have like a company that's like running a lot of their services, in a Kubernetes environment like Kafka and database, and you want to connect to those environments, right? So you can just deploy your Quarkus container over there, and then you can just develop as usual, and that's fine. You don't have to worry about setting a lot of things up, right? Okay, a couple of things. So you see that there is these application properties. So that's where all the Quarkus configuration goes. So there's nothing out in particular over here, just like the port that's running, like some logging stuff, Kubernetes configuration, and it's just like passing some properties. This is like the remote dev configuration. So it just actually uses a password. So you don't have other developers connecting to your Quarkus environment if you don't want that. So, but it's very simple. Now let's go with a more. Let's see how much time I have. Okay, let's go with a more tricky, well, not say tricky, but a more complete example. So this is a book API. So book API, you'll see there's more complete code over here. There is like persistence, right? There is like a repository using entity manager, so it has like a database, right? Let's see. I also think I have somewhere over here. Yep. So there's also a Kafka queue involved over here. So there is we're calling this reactive messaging using that emitter. So there, you'll see there's a more complete application. There's a database, there's like a Kafka queue. And well, how do I start this application, right? I know that I need a database, I need a Kafka, so I need to probably have like a Docker, compose, and start those services up, because if I don't, my application is going to blow up. Well, not with Quarkus. So I'm going to run Quarkus dev. So what Quarkus is going to do in this particular case, it's going to look into application, it's going to look that you have a database, and if it's not able to find a database to connect, it's going to instantiate one database for you. The same thing with the Kafka connector, right? And what we actually do over here is we create those with test containers, in the sense that when you stop Quarkus, then all of those go away as well. Now, for instance, if you're running on a business or a company that you're not able to have Docker installed, there's also something called the test containers clause, which Quarkus already also uses. And if you're not able to find the Docker environment in your local box, and if you're able to find the test containers clause, it will just create your database and Kafka queue directly in the test container clause. And then when you shut down Quarkus, then all of those go away. So if you see over here, this Quarkus took a little longer to start because he had to start database, had to start Kafka. But again, the idea over here is to give you like a very smooth development environment. You don't have to worry about everything. Quarkus will try to handle all of these things for you automatically. Well, now you have, like you'll see, well, where is that? So dev services. So we call these dev services, right? So you'll see that we started the database Postgres, and we started where is that? It's over here. There is the Kafka queue over here that's being started. And well, then you're done until you're able to start. So we only have like, I think, a few minutes left. I think I don't have to show too much about that application. I just wanted to show dev services. So this works with a lot of things, Kafka queues, of course, database, not only Postgres, but the most popular ones, a lot of other services. So we'll just check which ones we support. And if you don't support it, just ask them, and we'll just add it. Spring. So I told you I was going to show some Spring APIs. And I'm sorry, I'm not really a Spring user, so I don't know these by memory. But I have these here. So I'm just going to unshelf this. And maybe, so I know this is a small example, but still, let me refresh the IDE. So these reds go away. This is more, you recognize these, right? OK. So this was from my last demo, so let's put it like this. And OK. So now we're going to run Quarkus dev again for the Spring APIs. Actually, I haven't even downloaded the Spring APIs. So, well, Quarkus is running, right? And that was just a very simple one, just called greeting. And, well, let's call greeting tweez. No? Ah, sorry, I think it doesn't have that one. There you go. And of course, this supports live reloading stuff. So now you have Spring APIs with hot reloading in a Quarkus container. So if you don't really want to use the other APIs that I've shown you before, yeah, you can just come and use the Spring APIs using REST controller, request mapping, and so on and so forth. We don't support all the Spring APIs. We support the most popular ones. So if you want to write simple, like a REST endpoint using Spring APIs in Quarkus, you're done. The only difference that I added over here was just, well, of course, the controller, and just added the Spring Web extension from Quarkus into the project, and you're done. And it's going to behave exactly the same as I've shown you with the other stuff. Final thing, I have 3 minutes left, I think. Native image. So I'm going to build a native image now. These are also already out of the box. So this is, do you have any C developers over here? Or you built C in the past? Okay, a few. You know how hard it is to build C applications, right? It takes like ages to build. So this pretty much is very similar, right? Because you're building a native executable of your code, right? So the recommendation over here is not, well, you're going to build native image every time you do a change, because that's not going to be scalable, because it just takes a lot of time. So what we try to do with Quarkus is we try to give you the same developer experience as you will have by running the code on the JVM or running as native. So the recommendation is you just develop your code on the JVM, use exactly what I show you, running tests, running the application, and then when you're happy with that, then you can just build the native image, and then you can run. So a popular way to do it is just leave the CI to do that for you once you're done with your changes, and you do the commit, and then CI can just create the native image for you. Again, because as you can see, it's still building, right? This is not really scalable, but it's almost done. Usually, it may take like 2 minutes, 3 minutes, depends on your box. Depends, of course, of the application as well. For this, you need GraalVM, and you need the native image package from GraalVM over here. So we have 1 minute left. I hope this will build in 1 minute to show you. So I know it's mostly done. Come on. Creating image. Almost there. There you go. I'm also running tests. The tests are going to actually use the native image that was now executed, the same thing that we've done with the Docker way, it's also used the native image that I executed or that I generated. So if you ls target, you'll see there is like a number API running over here that seems like to be an executable file. It's 59 meg. I'm going to do something that you should never do, right? So I'm going to cat this. You never cat binary files, right? That's a binary file, right? OK. How do you start binary files? Like that. Oops. So yeah, I have a port running. It's the one that's running on Kubernetes. Let's just do like this. Quarkus HTTP port 1990. It was instant. Did you catch that up? Maybe not. I'll run that again. Done. So this took 44 milliseconds to start. And it doesn't have greeting because it's not running on that port. So 9090. So greeting, it's over there, right? So you still have all the same things that you have. Now, you're not going to have live reloading. Forget about that. I mean, this is a native executable. So it's not, I mean, there's no live reloading. But the behavior of the application, the code application is going to be there. It's going to have all the things, REST endpoints, everything that you develop. And again, if you're using Quarkus extensions and you're building native and something doesn't work in native, that's a bug and you should report it. Because everything that you build for the JVM should also work in native when you're running a Quarkus app. And let me just show you this. So this is number API running. See, it's 20 meg. Right? If I run, well, I'm going to read Quarkus. That's going to take a little more memory. But if I run the Quarkus dev for the book API, it's going to be like 100 something, right? So I don't think. I mean, you know how much memory Java takes, right? But yeah, I think that was everything that I wanted to show you demo-wise. I'm not sure if you have time for questions. Maybe we have, maybe we don't. But thank you so much for attending. And if you have some questions, I'm happy to answer them. I do have some Quarkus T-shirts if you want for everyone, for people that ask questions. Or if you don't, I'll just throw them away, and you'll pick them up.
We don't have time for questions.
Sorry? Huh?
You need to catch Roberto after the presentation because we don't have time for questions.
Sorry.
Thank you very much in that case.